Hey, so today we have a differential equations, a problem from I believe it's 2017 spring final from CCNY. We're going to focus on the salt problem, and it starts off like this. A 200-gallon tank initially contains 50 gallons in which are dissolved 5 pounds of salt. The tank is flushed by pumping pure water into the tank at a rate of 3 gallons per minute, and a well-mixed mixture is pumped out at a rate of 2 gallons per minute. And it says compute the time when the tank has filled. Then write the initial value problems, which describes the amount of salt in the tank at any time before the tank is full. You need not solve the problem. So that's a very important detail, that we don't need to solve the problem, we just have to set it up. So let's write down details. So we have, first of all, there is let's just write it down. We have a 200-gallon tank. Okay. It says that it contains 50 gallons. Okay. In which are 5 pounds of salt. So there's 5 pounds of salt already in the tank, okay? But that initially, when setting up the problem, that's not really important. So what I'm gonna write here is, okay, we have 200 gallons, but I'm gonna write this in, and I'm gonna write out, okay? So I'm gonna write something like this, minus something like this, okay? So we're gonna write here concentration. Okay, here we're gonna write rate. Once again, I am going to write concentration. Okay, and here I'm going to write rate. Okay, so we have concentration times rate minus concentration times rate. And notice here it says in and here it says out. So this, everything right here is going to go equal to dq dt. Okay, so this is how our differential equation should look like. So reading back from this problem, we're not really looking at what was already in the tank. We're looking at the water that was going into the tank. And as we look into the problem, it says it's flushed by pumping pure water into the tank. That means that when the water is coming in, so if there's a tank, okay, there's water flowing out, and also water flowing in. Okay, let's just say, okay, so there's water flowing here, here it is mixing, and it flows out. Okay, we're looking at this water, and the concentration of that water coming into the tank is going to be 0. Okay, now just for the sake of this problem, I'm going to continue writing in this rate, although we know that if this is 0, then this is going to cancel it out, because 0 times the rate is going to equal to 0. But 0 times the rate, what was the rate that it's going into the tank? Let's see. It's flushed by pumping pure water into the tank at a rate of 3 gallons per minute. Alright, so I'm just going to write 3 gallons per minute. Okay, I'm going to write minus here. Okay, now let's check out the rate that's coming out. So it says, okay, and a well-mixed solution is pumped out at a rate of 2 gallons per minute. Okay, so 2 gallons per minute. Okay, and what is the concentration? Now, this is what we wrote here. There are 200 gallons. That's where the significance of it comes into place. So we're gonna do a fraction. First of all, we're gonna write the 200 on the bottom, okay? Because remember, concentration is how much there is of something over how much there is of everything, right? So, like say 5 pounds of salt in 200 gallons of solution, right? So you're gonna write 5 over 200. So that's just a concentration example. So we're gonna have 200 here. Now on top we're gonna write Q. Now, this right here is very important step, because what's going on? We're having 3 gallons of water coming in and only 2 gallons of water coming out. That means that every minute there's more water coming in and then coming out. So what we have to do is take this rate. So in this right here, this is in rate minus out rate. Okay, so we have the in rate minus out rate. So what's the in rate? The in rate is 3 gallons per minute, and the out rate is 2 gallons per minute. Okay, so then we have 3 minus 2 is just 1 gallon per minute. That means that every single minute there is an additional gallon being pumped into the tank. Okay, so if we rewrite this, we're going to get 0, right? 0 times 3 is just 0. We're going to have minus Q over 200 plus 1. And remember, T for time, right? Because we're going to write, because every single, our variable is going to be T, because T is minutes. Okay, so we have 1T. Okay, times the rate of the water coming out, so it's just going to be times 2 equals to dq dt. And then if we simplify this even further, I'm going to write the dq dt on this side, dq dt. Okay, here it's going to be minus equals to negative 2q over 200 plus 1t. Okay, so here it is. We set up the equation. Now, we are not finished yet, because we have to give initial conditions, because there was already a concentration of salt inside the tank before there was any water coming in or coming out, right? And let's review what it said here. It says here that a 200-gallon tank initially contains 50 gallons, in which are dissolved 5 pounds of salt. So, in order to make sure that we write this in here, we are going to write Q of 0. That means that times 0, right? When T equals to 0, there is already 5 pounds of salt. Okay, so this is significant. Right, so we have our differential equation, which we didn't solve, but they didn't ask us to solve. And then we have the initial conditions saying that there is already 5 pounds of salt dissolved in the water. That was already here. Okay, so our last step is they asked us compute the time when the tank has filled, then write the initial value problem. Okay, so compute the time when the tank has filled. So we know that the tank has a capacity of 200 gallons, yeah? And initially it contains 50 gallons, right? So this is how much it can have, but initially it has 50 gallons. So I'm just gonna subtract this, okay? And this equals to 150 gallons that are unoccupied, right? So if there's a tank, it has a capacity of 200 gallons, only 50 is actually filled, right? So the remaining part is 150 gallons that are unfilled. Now, if we look back here, it said that it was going at a rate of 1 gallon per minute. Okay, so how many minutes would it take, or how many minutes would it take for this tank to fill up at a rate of 1 gallon per minute, right? So we have per minute. So after 1 minute, that will be 1 gallon. After 2 minutes, there'll be 2 gallons. If you see this pattern, what I'm trying to say is that after 150 minutes, there will be 150 gallons. So we take this, so these unoccupied space, so we take 150 divided by the rate. Okay, so we're gonna do divided by 1 equals to 150 minutes. Okay, and there you go. It would take 150 minutes to fill up this tank to its capacity. Okay, and here we go. Well, I hope that helped you out, and good luck with your studying. Thanks.